welcome to another video of the MSU Denver video walkthrough of the Elementary Acupuncture Study Guide. In this video we're going to be talking about distribution and factoring basics, just the basics, because in a few sections, in a few videos down the line, there's another factoring video and distribution that we're going to be talking about, a little bit more complex stuff. So in this video we're just going to be going over the basics, and then the first thing we're going to talk about is distribution, because, well, it's easier, at least the basics are. And so what distribution is, and what I want you to do is, it's basically multiplying, right? But it's multiplying in such a way that you make sure you kind of multiply groups of things together, and that everything kind of hits everything else. And so most essentially, I could say in its most basic form, I could say, well, 2, and in the parentheses I could say 3x, and that's it. And if I multiply these two, well, I can say I'm distributing this 2 to that 3x, and that becomes 6x, and that's it, right? But again, you don't really think about that being distribution. So instead we're talking about groups of things. So another easy one, but a little bit more complex, is if I just have 5 and I multiply that by, let's say, x plus 2. And in this case, I can't add x plus 2, right? And so there's nothing I can do. And so this is a time where I'd want to actually distribute this 5 through there. And I distribute it through because I can't just say 5 times and then the first thing that comes up is x. So 5 times x plus 2, right? Because if I'm saying 5 times this whole thing in here, x plus 2, then I need to make sure that I distribute this through to each term in there, right? And so when I distribute it, I have 5 times this first term is x, 5x, so 5x, and then 5 times that second term is 2, so 5 times 2 is 10, so it's 5 plus 10. And it works out because if I could say that 5 times x plus 2 is the same thing as if I have x plus 2 plus x plus 2 plus x plus 2 5 times, right? And when I read it along along like that, and then I add and I simplify everything together, I'm going to get 5x's plus 10. And so and so distribution is basically multiplying groups of things together and make sure you multiply all the things correctly together. And so this one's not too bad, and that's mostly what we're going to see in this section in the distribution. But I'm going to dip in a little bit farther, where we're actually not going to go into this in these practice problems. But if I have something like x plus 2 and I multiply that by another group, say x plus 3, right? This is a time where we really need distribution, and we needed it in the previous problem. But in this sense, I would need to make sure this x over here, this left-sided x, it hits everything over here, so that x and that 3, and then this 2 also hits everything over there, right? And so you might remember the term FOIL, first, outside, inside, last, and that's how we kind of make sure that we kind of touch everything and multiply everything that we need to together, inside, last, and what that's referring to is first is this x times this x in there, and that's the first one. Let me actually erase some of this stuff so it's a little more clear. That these two x's multiplied by each other, that's the first thing. Outside, well, this x is on the outside, that 3 is on the outside, so we're going to multiply those together. Inside, these two inside things, and then the last is that 2 times the 3. And that works for, some variable plus some number, so x plus 2, and then times, and then there's 2 other things, right? But really, to get even more complicated, I'm not going to go through this one, but I could even have x plus 3, and I times that by, x plus y plus, plus 7. And then, it gets even more complicated, and you're going to use distribution then. But for the basics, what we're going to be talking about in this video, I'm going to erase all this stuff, and we're just talking about, kind of distributing that 5 up here through what's in the parentheses, right? And maybe it's x plus 2, maybe it's x plus 2 plus y, but it's just distributing that one thing to the group. And so for factoring, factoring's kind of undoing a distribution. And there's more complex factoring, but in these problems, in the basics, we're looking at the biggest thing that we can pull out. And so if I had something like, let me just write down what I just did. I have 5. Let me write down the answer, 5x plus 10. And I ask myself, if I want to factor something out, what's the biggest thing I can factor? Well, and typically you want to factor out the biggest thing. Sometimes you don't. Sometimes it behooves us to factor out something smaller. But typically, especially for these next couple problems, we're going to be factoring the biggest thing we can. And so the biggest thing I factor out of this one is, first I look at the numbers and I say, okay, what's the biggest number that they both have in common? In this case, it's 5, because the 5 has a 5 and then 10 has, I can break that down to 5 times 2. And you want to be left with whole numbers, right? I can't say, well, the 10, well, I can divide that one by 2, but if I divide the 5 by 2, well, then I get a fraction, right? So whole numbers, but if I pull out a 5 from each of those, and I can think about the x too, but I have an x in this term, and I don't have an x over here, so I can't. There's no x's to pull out because they both have to have that same thing in common. So 5, and then I ask myself, well, what's left? Because that's what's going to go in parentheses, right? And to ask myself what's left, what I do is I divide this term over here, and I do it term by term. I divide it by what I pulled out, right? So 5x, and if I divide it by 5, then I have what's left is x. And if I take the 10 and divide it by 5, what's left is 2. And so if I factor out a 5, that's what I did there, is I factored out a 5. What I have is 5 times x plus 2. And that's helpful for, what if this whole thing, what if I had 5x plus 10, and I wanted to divide that by 5, right? Well, then it behooves us to factor out the 5 times x plus 2. That's still divided by 5. And then I can say, well, 5 divided by 5 is just 1, so that will simplify to x plus 2. And so that's why we factor out. Typically, we factor out to be able to simplify stuff. And then the other reason we factor stuff is to solve for something. Maybe we're solving for x in a quadratic formula, which you may see later. But in this basics video, all we're doing is pulling something out. And we're pulling out the biggest thing. There may be times when that's not the most beneficial thing to do, but we'll get there and we'll walk through that as it comes up. And so that's it for these videos. Going in straight into the practice problems, I'm going to do, let's see here. So if you're following along in the study guide, we're on page 24, and on page 24, I'm going to do so I'll write this right here, page 24. I'm going to do number 2 and number 3. In particular, I just wrote down page, not page 2/3, page 24, number 2 and 3, because they're distributing. And then if you go on to page 25, actually page 25 is pretty much the same thing that I just kind of talked about, except they're, in that particular case, they're just asking you to factor stuff, which, in some of these practice problems are asking you to factor stuff as well. So in that case, I'm just going to do kind of both. They're not really sections because they're both basics, but I'm going to do page 25, and I'll just do the odd ones there. So I'll do 1, 3, and 5. And then I encourage you to do the ones that I don't know why I put a comma after the and. Do the problems that we haven't done, that I don't do, just for more practice. And then again, if you have any problems, please come into the tutoring center. And so let's just jump right into this, because that's the easiest way to do things usually at this point. So number 2 that we're going to do on page 24. Number 2 says 2x times 10y plus 7x. And if we look at the directions just say, hey, distribute and factor, whatever, the following problems. And so you might be like, oh, well, what do I do? Well, if there's parentheses, if it looks like we're supposed to distribute, then that's what I would do. I would go ahead and distribute if there's parentheses. And if there's not, if it's just a whole bunch of different terms, it probably wants you to factor it out. So it's not really specific about what it wants you to do. But we can figure it out. And then actually on the next page, it actually says, hey, factor this stuff. So we know that's what we're going to do there. And so in this one, we're going to distribute. And so what am I going to distribute? Well, I'm just distributing. Like I said, there's not multiple groups that we're distributing together. It's just one term times a group. So we're taking this 2x and we're going to distribute it into that parentheses. And so we got to multiply by each thing in there. And so it's pretty easy. The first thing I'm going to do is start with numbers, right? So the first term in the group, right, 2x times 10y, I look at the numbers, right? So 2 times 10, that's 20, and that's what I get. And then recall back to when we were talking about exponents, is if I have a, and a can be any letter or any number really, let's say it's squared, and if I have like a cubed, and I multiply those two, so as long as a and a are the same, whether it's x's or y's or 2's or whatever, then I can just add their exponents together, and that becomes a to the 5th power. And so that's what I want to kind of do here is I want to, if I'm multiplying an x, and we'll see that in the second term, but in this first term, also recall that any, and I'm going to use a's here just because a's are more general. They can do x's and y's or whatever, it doesn't matter. But anything to the 0 power for now is just equal to 1, right? And it's actually quite interesting about why that is, and you can look that up. I'm not going to get into that, but anything to the 0 power is 1 for now. And so if that's true, then I could say, well, because there's no x's here, and if there aren't any x's, you can just say, okay, well, then it's just whatever x's is, and that's x, and there's no y, so it's whatever y is, so there's just a y there, and that's what it is. But I could rewrite this, and if this is going to confuse you, then don't worry about it, but I could say that this right here I could say that's 10, I could say that's x to the 0 y, right? Because x to the 0 is this 1, and so 10 times x to the 0 times y is 10y, right? And now I have x, and I'm multiplying the x's together. X to the, well, anything to the 1 is just itself, so since it doesn't have exponent, I can say it's x to the 1. And so since I'm multiplying x to the 1 times x to the 0, I add it together, right? So 1 plus 0 is still 1, and so what's left is x to the 1, right? Or just x, and so that's what I come up with. It might be easier just to say, well, there's no x's there, so, but that's why that's true, right? And so this first term is going to be 20x, and then I could say, well, 2x, again, just kind of going into what we just went into, I could say that's 10, that's 2x, and then times y to the 0, because y to the 0 would be 1 as well. And then that y to the 0 times this y to the 1 is y to the 1, and so that's why we got the y there. But again, if it's just, if that's confusing at all, or, just say, oh, there's no more x's over in the second term, so it's just what I have left, right? All right. In my second term, right, and here's how we're gonna use this actually over here, kind of more in depth. I have 2 times, again, the numbers first, so 2 times 7 is 14. And then I have an x to the 1 over here, I have an x to the 1 over here, so x to the 1 times x to the 1, just what we looked at over there, we add them together, so that becomes x squared. And then we don't have any y's, and so I could say, well, y to the 0 plus y to the 0, or times y to the 0, 0 plus 0, 0, so, but you could just say, there's no y's, so that makes more sense. So number 2, when I factor it through, is just this over here, 20xy plus 14x squared. I undid the factoring of if I factored out 2x. I distributed that 2x, and that's what I get. So going on to number 4, we're going to distribute again, and then we'll jump onto page 25 where we actually factor stuff out. So number 4, put a little squiggly mark. Number 4 says I got 2g to the 6th, and then I'm going to times that by the grouping of 3 plus y to the 7th. 3 plus y to the 7th. All right, and if I distribute this through again, I just gotta make sure it multiplies by everything. So 2 times 3, that's 6, that's nice. G, there's no g's, and try to be careful about distinguishing your g's from your 6's. But there's no other g's in that first term, so I just have what I have, and that's g to the 6th. So that's my first term. My second term is, well, 2, and then there I could say there's a 1 in front of the y, right? The coefficient. If there's not a coefficient there, if I don't see it, it's just a 1. 2 times 1 is 2, so I have a 2. G to the 6th, I don't have any g's in that second term, so that just remains the same, g to the 6th. I don't have any y's in the terms that I'm distributing through, so this just becomes y to the 7th, and that's my answer, is g to the 6th, 6g to the 6th, plus 2g to the 6th, y to the 7th. And so I'm not gonna make a whole nother video for this next page. I'm just gonna move on to page 25. I encourage you to do problems 1, 4, and 5 from page 24. But moving on to page 25, we can actually factor some stuff out. So I'm going to draw a line right there, put a little page 25 here. And I said I was going to do the odd problem, so jump off with number 1, and that's 6x plus 2y, right? And it doesn't, it does tell us to factor here, but if it didn't, if it says, hey, factor or distribute, well, I'm not multiplying anything, there's nothing to distribute here, so I know I'm not going to distribute, so instead I'm just going to go straight to factoring, but it actually tells us in these examples to, hey, factor these. And so if I'm going to factor, I ask myself, again, what's the biggest thing these things have in common? And I start with the numbers, and then I go to the variables. And so the biggest number they have in common is, well, this one has a 6, but this one is only a 2, so, and the 2, I can pull a 2 out of the 6, so as far as numbers go, I can pull a 2 out. And then as far as letters go, I have an x here. I don't have an x here, so I can't pull out an x. I have a y here. I don't have a y in this one, so I can't pull out a y. So it's just 2. That's the biggest thing I pull out. And again, sometimes you don't want to pull out the biggest thing, but in this case, in these practice problems, that's what we're going to do. So 2, and then what do I have left, right? Well, I take the terms, right, and then I divide by what I pulled out. And so 6x divided by 2, and what I have left is 3x. And then 2y, and I divide that by 2, and what I have left is just y. And it's very easy, actually, to check, and it's actually good to check, too, because it helps you with your distribution if you need help with that. But if I distribute this 2 back through, I should get what I started with, excuse me. And so if I multiply 2 times 3x, I get 6x. If I multiply 2 times y, I get 2y. So we know we're good. All right, that was pretty simple. Okay, that's number 1. They should get a little bit difficult. If they don't, these are pretty basic. We will go into more in-depth factoring and distributing in a later video. So number 3, and again, I encourage you guys to try the ones that I'm not doing. Number 3 says 12z squared, and I differentiate my z's from my 2's by putting that line in there. Y, not why do I do it, but there's a y there. I'm so funny. Okay, 144 y squared. And then I ask myself, okay, the biggest number I can pull out, and if you're familiar with squares, perfect squares, then you know that 144 is 12 times 12. So I could pull out a 12 out of each one. So this is 12, and then the letters, the variables I pull out, I have a z squared here. I don't have any z's in my second term, so I can't do anything with z's. I can't pull any z's out. I have a y here and a y squared here. So while I can pull out a y squared from the second term, I cannot pull out a y squared from this first term. Or you could, but it gets into some difficult stuff that we're not going to talk about. We're not going to do that kind of stuff. And so what I would have left here is I don't want to pull out the y squared. I want to pull out what I have, and because that's kind of like, oh, I have a 12 here, and I'm going to pull out a 7, right? You're going to get into weird fractions and stuff, and so we're not going to do that. And so I'm only going to pull out a single y. And so I pull out the single y, and then I ask myself what I have left. So I, each term, like we've been doing, I divide it by what I pulled out. And so 12z squared y, if I divide that by 12y, well, 12 divided by 12, again, I go number by number, letter by letter. 12 divided by 12, excuse me, talking kind of fast. 12 divided by 12 is 1, so I'm not even going to put the 1 there. I could. Z squared, well, I'm not dividing by anything, so I'm going to skip that one. And then y divided by y is 1. So I have a 1, and then times z squared, because I didn't reduce it at all because there's no z's in what I pulled out of. Okay, and then my second term is, well, 144, again, if I deal with the numbers first, 144 divided by 12 is 12. And then y squared divided by y, back to exponents. Remember, if I have a y squared and I'm dividing by y, it's like a squared divided by a, and I can subtract the exponents, just like if I multiply them, I add the exponents. So this becomes y to the 1, or just y. Or you can think about it as y times y divided by y, and then 2 of the y's cancel out. You're left with just y. So however you want to do it, but there's a y left. And so when I factor out a 12y, what I'm left with is 12y times z squared plus 12y. And again, it's easy to check if I distribute that 12y back through. 12y times z squared is 12z squared y, and 12y times 12y is 144y squared, which is what we started with. Moving on to number 5. Oh, this one looks fun. Negative 25 x to the 7th power y squared plus 10 x y to the 5th minus 50 x to the 12th, y to the 7th. All right. And so whether you have 2 terms or 3 or 5 or 8 or whatever, you're not going to see anything that big. But just go term by term, right? And number by number and letter by letter. And so let's go with numbers first. And the biggest number I could pull out, well, it should be readily apparent that it's going to be a 5. I could pull out a negative 5 if I wanted to. It just depends on what you want your answer to look like. And if you pull out, let's say, a 5, and that's not an answer, and instead maybe their answer, they pulled out a negative 5, well, just ask yourself, okay, well, if I pull out a negative 5, you can kind of check yourself against the answers and then pull out a negative 5 instead, and that would change all the signs, and you should get the same the answer that they have. But whether you pull out a positive or a negative really depends on the reason that you're doing it, right? if I was going to cancel something out below it, and maybe below it was a -5, I'd want to pull out a +5. And so I'm going to just pull out a regular 5. And maybe that works, maybe it doesn't, maybe it's not the same answer. Actually, let me check the answer and see what they're doing. I don't like to do this before I start the problem, but they pulled out a regular 5. And that's what I would start with anyway. And if that wasn't one of the possible answers, A, B, C, or D, then check if it was a -5. But anyway, so I pull out a regular 5, right? Because I pull out a 5 out of 25, out of 10, and out of 50. I can't. Usually, I go with, well, what's the smallest number that's there, and that's a 10. And can I pull that out of each term, right? Because I can't pull anything bigger out of a 10. But I can't pull a 10 out of a 25, right? And so then I go down in increments, and I get to 5. And so my first letter is my first number is a 5. And then I look at the x's, and the biggest x I can pull out. Well, I have 7 x to the 7th here. I have x to the 12th here, but I only have x to the 1 here, right? And that's what you're looking at. You're looking at the exponents, because you can pull out the biggest exponent that you can pull out is the one that's the smallest, right? And this one is x to the 1, so I can only pull out an x to the 1, unfortunately, even though the other ones have a lot. And as far as y's go, I have a y to the 7th here. Y to the 5th there. I have a y to the 7th here. But here I only have y squared, right? So the biggest one I can pull out is whatever the exponent is, the smallest. So what I'm going to pull out is a y squared. So the term that I'm factoring out is 5xy squared, and then I put parentheses. And then I ask myself, well, what's left? And so I'm going to take this first term, and I divide it by 5xy squared. And again, if you think about it number by number, letter by letter, it's a little bit easier. So -25 divided by 5 is -5. X to the 7th divided by x is x to the 6th. Again, you can do what we did up here and kind of cancel the exponents out. Y squared divided by y squared is simply, well, that's 1, so that's it, right? I'm not going to put the 1. Plus, and I'm going to put a plus because I have a positive 10 here, and I'm dividing by a positive 5, so that's just a 2. X divided by x is 1, so I'm not going to put that down. I have y to the 5th divided by y squared. Y to the 5th divided by y squared. So I can, since I'm dividing, and they're the same, they're both y's, since I'm dividing, I can subtract their exponents. So 5 minus 2 is y cubed. So y to the 5th minus y squared is y cubed. And then I have a -50 divided by 5, so that's -10. X to the 12th divided by x, that's just x to the 11th. 12, oh, I don't know why I put a 12 there. 12 minus 1 is 11. And then y to the 7th divided by y squared, 7 minus 2, so that's y to the 5th. And again, I'm not going to do it this time because I want to kind of make this video shorter. But if I distributed 5y squared throughout the thing that what's in parentheses, I should get, and I will get, what I started with. So that's it. That's this video. It's just the basics, and maybe you're familiar with all that already, and you're like, well, there's a lot more to factor in. There's more distribution, but we will get into that in a later video. All right. If you have any questions about either the problems that I did or the problems that I did not do and you try to do, please come into the Tutoring Center.